Hello everyone, this is Marcelo from PNCC, and in this tutorial we'll show you how to perform the direct alignments on a 200 kV microscope equipped with fringe-free illumination. For this demonstration, we'll be using our Glacius 2 instrument. First, open the column valves and make sure the flue screen is inserted. Next, open the direct alignments panel. If we use the intensity knob, we'll notice that in this system, we can never reach the crossover point, even when going through the entire C2 lens strength range. That means from 0%, a very weak lens condition, all the way to 100%, a strong lens condition. The electron beam will never convert into a crossover. Alright, our first goal is to achieve parallel illumination. To find parallel illumination on a two-lens condenser system, make sure that you have loaded a cross-grating grid, the sample is at eccentric height, the flue cam is inserted, and we're using the pixel size intended for data collection. Next, switch to diffraction mode by pressing this button. As we can see, the beam is far from parallel, so the first thing we'll do is focus the beam into a spot using the intensity knob. Now select the diffraction alignment function and use the multifunction knobs to center the beam. Next, left-click on the flue cam window. Using the mouse wheel, adjust the screen brightness to a level where the diffraction rings from the cross-grating calibration grid are clearly visible. Good. The next step is to insert the objective aperture. Let's open the apertures panel and click here. Now we have the 70 micrometer objective aperture inserted. Alright, now we need to offset the objective aperture. Click Adjust and move the aperture away. Something like this looks good. The goal here is to make sure the objective aperture itself is in focus, and to do that, use the focus knob. At this point, we're not focusing on the diffraction rings, but rather on how sharp the image of the aperture appears. This can be a bit subtle and may require some practice. A useful tip is to go out of focus intentionally. When you do, the projected image of the aperture becomes blurred or diffuse. Then, carefully bring it back into focus until the edges appear sharp. Once you get the sharpest image possible of the objective aperture, we can call it good. Now let's gently adjust the intensity knob to make sure our diffraction rings are well focused. This step is easier than the previous one, but it helps to slowly turn the intensity knob back and forth over the crossover point. Alright, that looks good. We have ended up with a C2 lens strength of 44.2%. Make a note of that value, because this setting gives us parallel illumination every time we set the C2 lens to this strength. Now let's remove the objective aperture by clicking here. Since we're still in diffraction mode, we can take this opportunity to center our C2 aperture. To do that, let's go back to linear mode in the flue cam settings and make sure the beam is well centered. Let's spread the beam a bit, around 52% should be good. And then open the apertures panel and click Adjust. Now, use the multifunction knobs for aperture X and Y to move the aperture horizontally and vertically until it's centered as best as possible. Once it looks centered, click Adjust again to exit and use the intensity knob to return to 44.2% on the C2 lens. That brings us back to parallel illumination. Alright, let's bring back the microscope to imaging mode by pressing diffraction on the right control pad. In the Direct Alignments panel, let's check the beam tilt pivot point X by clicking here. Remember, on this system, we can't use the intensity knob anymore, so we need to adjust the pivot points using the beam as big as it is. Now, using the multifunction knobs for X and Y, try to bring these two beams together by minimizing their movement. Repeat the same process for beam tilt pivot point Y. Now, let's center the beam around the detector area using beam shift. And then, check the rotation center to make sure that the beam is along the optical axis of the objective lens. It is pretty decent already, but I can make it worse for the purpose of this tutorial. The goal here is to minimize sideways movement of the beam. Perfect. That's what we want. Click Done. And this wraps up the main steps of the direct alignments, and your microscope will be in great shape for data collection. Besides, this is always a great check to perform before running the auto functions in EPU. Alright, thanks for watching this tutorial. If you found this video helpful, please like and subscribe, and feel free to leave a comment below with any questions or requests for future videos, and we'll be happy to answer them.